Okay, here we go. Number one. Should have had the following in your proof. Obviously, the givens for statement and reason one. And statement two should have just been that GEF was congruent to KHJ because halves of equal quantities are equal. You guys already had the half statements here. You already had the pair of equal quantities. So all you needed to write in was halves of equal quantities are equal. All right. On number two, this was a subtraction proof where we were already given both pairs of equal quantities. So therefore it was given, subtraction, substitution. Given, subtraction, substitution. You already had both pairs of equal quantities. All right, let's go to the next couple here. All right, with three you had to do a little bit more work for. What keywords did you see in number three? Bisect. So that tells me I'm going to use which one of the postulates up there that are gone now because you're having a quiz, but which one I'm probably going to use if I start seeing bisects and midpoint? Halves of equal quantities. All right, so this is a halves of equal quantities proof, but you need to tell me the half statements first. So your first half statement or your second one, or whatever order you wrote them in, should have read that half of AB equals AD. And the other half statement is half of CB equals CE. And how do I know that it's half? Because it's the definition of a bisector. Then in step three, you could say AD is congruent to CE by halves of equal quantities are equal. Okay? Everybody all right? Any questions? Yes. Definition of a, what word came up? Bisector. Okay. All good? All right. What is that number? Is that 4? Okay, that was the little change up. Hopefully you realized it just wasn't all subtraction. This wasn't an addition one. Okay, because look at your given to your proof. You are getting bigger. The line segment is getting longer, so I needed to add. And notice how many equal quantities did I give you? Just one pair. So you could not add in step 2. You needed to show me the other pair of equal quantities, which was DE congruent to DE, reflexive. All right, so statement 2 should have been DE congruent to DE, reflexive, addition, substitution. So that was a 4-step proof. All right, for number 4. And number 5, what word pops up again? Bisect. So hopefully you put somewhere in your proof halves of equal quantities are equal, but you were not given half statements, so you had to write them on your own. So here are your half statements. Half of CAB is CAD. Half of CBA is equal to CBE. How do I know that? Definition of a bisector, and then finally in statement 3 and reason 3, you could have your halves of equal quantities are equal. Anything on those 3 that we want to touch upon before I go on to that last one, which was another subtraction one? All right, the last one was subtraction, but again, quickly, how many equal quantities did I give you? 1, so you needed to find the other one on your own. So step 2 is not subtraction. Step 2 is angle. MQN is congruent to angle MQN by reflexive. Then you could subtract and substitution. Do substitution. Okay? Anything? Yes. The one, well, look, take a look. You're going LQN, right? LQN, and you got to prove that LQM. LQM. So what am I going to have to subtract from this yellow angle? MQN, that one in the middle. Let me put arc marks on there instead. So here is the angle you're given right there. See that angle? And you are trying to get to this angle right there. So what do I have to subtract from the larger angle to get that one? I have to subtract this angle, don't I? MQN. It's the same thing when I go MQP to NQP. Okay, so I need to subtract that reflexive angle out before I can subtract. Other questions or concerns? Okay, I just want to remind people, that this quiz you're about to take in the 10 minutes does not have halves of equal quantities or equal on it. Meaning, what should not show up on your paper? Halves of equal quantities or equal. All right. Sorry I had to take the others down, but it's a quiz. All right. So I'm going to give you 10 minutes. All right. So we'll go to a little after 11:15. You've needed two quantities to add and subtract, and it's been very convenient when you add and subtract. Why was it convenient? I either gave you both quantities, or I gave you one, and where'd the other one come from? Reflexive. So it's been nice. But now it's going to come from somewhere else. Okay? It's not going to be reflexive anymore. It's coming from somewhere else, which are going to be our angle theorems. All right? So take a look at this first one right now, that the theorem we're about to use, all right angles are congruent. Look at the given so we can mark our diagram. AB perpendicular to BD. What happens when two perpendicular lines are formed? This is going back to unit 1. Two perpendicular lines are formed. What's formed? A right angle. Mark the right angle on the diagram where AB and BD meet each other. And then you could do the same thing for where FG and DG meet each other. Okay, so go ahead and put those right angles in for me. I'll walk around making sure we put them in the correct spot. Please put those right angle symbols in the correct spot. Then once you get the right angles in, notice the second given. Angle ABC is congruent to FGE. I'm still nervous some people don't know how to label angles or find angles correctly. So go ahead with arc marks, ABC congruent to angle FGE. Follow. Guys, making me nervous here. Making me nervous here. We're in week 3 here. We're in trouble finding the angles. Here we go. Right angle, angle ABC is congruent to FGE. Oh, now I'm getting real nervous now. Can you find the angles I'm asking you to prove congruent? DBC and DGE. Can you find? Don't put any markings because they're not. We need to prove them congruent, so don't put any markings. But can you find those angles? DBC and DGE. I'm just going to put a little brown dot on them right now on my diagram so we can ensure that we're all in the same place. That angle right there and DGE, this angle right there. Everyone see them there. Got to prove that angle congruent to that angle. Everybody good? Okay. I need to ask you guys now, because this is something we have done. What am I going to have to do to your right angle and the given angle to get to the proven angle? What am I going to have to do to the right angle and the given angle to get here? Well, first of all, am I getting smaller or am I getting bigger from the right angle to this angle I'm trying to prove? Am I getting bigger or smaller? Smaller. So what do I have to do? Subtract. This is an obvious subtraction problem. But the issue is, how many quantities do you need to subtract? 2, and I only gave you 1. And this is not reflexive to find the other one. It's not going to be reflexive because take a look. There's not one angle that you subtract from both that give you those proven angles. All right, so I cannot subtract. But can you describe to me what angles are you going to subtract to get to DBC? Let's start here. Do you see the 2 angles I'm going to subtract to get to this one? It's the right angle and my red angle. Do we see that? Over here, how am I going to get to this angle right here? I'm going to take the right angle minus the red angle up here. Those are the 2 I'm subtracting. I already know these 2 are congruent. Have we told anybody that the right angles are congruent? No, we have not, and that's where this is going to come into play. All right? Again, how many pairs do you need? 2. You only have what right now? 1. So you need another pair, and that other pair are going to be your right angles. Okay? Before we say they're congruent, though, you need to tell me what angles on your diagram are the right angles. So I need 2 people right now to name me the angles. Name me one right angle up here. 18. Who's got 18? Okay, angle ABD and angle, name the other right angle in the diagram. 16. DGF are right angles. This is going back to day 1 of the unit. When we wrote down an angle was a right angle, we had a specific reason for it every time. If you need to go back and look, you go back and look. All right, but we had a specific reason for it every single time. All right, and that was what? What makes those right angles? Who's got 14? Do what? Perfect, Evan, thank you. Form right angles. Do I still have, how many pairs of equal quantities do I still have? 1, so we cannot subtract yet until we have 2. Here's how we get 2. These 2 angles are both right angles, so that means they are congruent. That's where this new theorem comes into play. So now I'm going to say ABD, the one right angle, is congruent to the other right angle, DGF. And when I say 2 right angles are congruent, the reason's going to be our new theorem, which is all right angles are congruent. That is how you get your second pair of equal quantities, so you can now subtract. So now this turns into something you can handle. Go ahead.
So do you have to write that step 2?
Yes, you have to, yes. Because here you go. Here's your reason. All right angles. I'm going to circle it, do a question mark, and say, where are they? Right? Because you marked it on your diagram is not good enough. It's got to go in here. Okay, good question. All right, now you can subtract. So tell me what pairs of angles you're subtracting. All right, tell me what pairs of angles you are going to subtract to get DBC and to get DGE. All right, here we go. Give me one pair of angles you're subtracting. Who's got 13? Give me one angle first. We have two pairs up here that are equal, correct? Okay. Tell me, give me a pair right now that's going to lead to either angle DBC or angle DGE. Okay, let's do this. Give me one of the right angles first. Angle ABD, and what are you subtracting from ABD? What's the only other angle next to it I know that's congruent? ABD minus ABC. This right angle right here, guys, this right angle minus that angle that was given to me. If I take that away, I'm going to be left with the angle I need to prove. And on the other side now, on the other side of the diagram, give me the two angles I'm subtracting. Here we go, 20. 19. DGF minus FGE. And the guys, this reason hasn't changed in the last 24 hours. What is it? Subtraction. And what we do after subtraction or addition hasn't changed either. Substitute to say, finally, angle DBC congruent to angle DGE. Substitution. So our proof is getting one step longer. But again, you knew it was subtraction, but I only had one pair of equal quantities. Where did the other pair come from? The right angles this time. And yes, you do need to say they're right angles before you say they are congruent. Anything you want to ask up here? Because as you can see, it's getting a little tougher now. Okay? Right angles, I can do the same thing, but for straight angles now. Okay, so I will give you a minute, set everything up, mark your diagram. I'm not going to mark mine. I want to make sure you can label these angles correctly. So get your statements, reasons set up, 2 columns, write your givens in, and mark your diagram before we start anything. Let's make a plan before we start writing down a bunch of mumbo jumbo that may not make sense. So we are given these two angles are congruent, ABF and EDC. And does everyone see the two angles I need to prove congruent? CBF, this angle right here, and FDC, I'm sorry, yep, FDC, this angle right here. So everyone see the two angles I need to prove congruent. Okay, so I know I got straight angles and I got these angles. What can I do to those two pairs to get the ones I need? You got your straight angle. That's given. You're going to this angle. You're getting smaller or bigger. From the straight angle, are you getting smaller or bigger? Okay, you answered the question already then. What are we going to do? Subtract. How many pairs do I need? 2. How many am I given? 1. So I need something else before you're allowed to subtract. What do you plan on subtracting ABF and EDC from? What should I subtract these angles from? And it's already given to you, but the straight angles. So I need the straight angles congruent. And that's what this new theorem says, is all straight angles are congruent. So now I could say that angle ABC is congruent to angle FDE. How do I know they're congruent? Our new theorem, which says straight angles are congruent. Before I move on, though, I want you to notice the difference between this one and the last one. Remember the last one when we said all right angles are congruent? Before we said that, didn't we have to say there were right angles? Well, the same thing applies here. Why didn't I write that there were straight angles, though, before? It was already given. Okay, so I didn't need to write that in. But if it's not given, yes, you do have to write that in. All right, so you got 2 pair now of equal quantities? Do we have 2 pair? Okay, tell me what you're subtracting now. Tell me what you're subtracting. Here we go, 3.
ABC.
Yep, ABC, and what are we subtracting from it? Angle. Nice job. And that will be equal to, name the other pair we are subtracting. Who's got 16? Yep. Nope, we haven't. Angle EDC. Good. And this is because of the subtraction postulate. And like always, that's not what we need to prove. We get to what we need to prove by substituting in CBF and FDC. All right. We okay there? All right angles, all straight angles. Okay, because of time constraints, I'm not going to do this one. Don't cross it out. But hey, let's just talk about it real quick. I just threw a review in there for you. This has nothing to do with right angles or straight angles. Anybody see anything in the givens right away that are like, boom, I know how to do this, Luke? Bisector. So guess which postulate's going to come up? Halves of equal quantities. All right, so I don't know if you want to make a note off to the side when we go back and finish this one, or you go back and finish it for review. Halves of equal quantities are equal. This has nothing to do with right angles or straight angles. It's just a little review for you. And beware of that tonight on your homework too, that I threw a couple halves of equal quantities in there tonight. Okay, final thing. I didn't want you to forget how to do some algebra. All right, so if you got your calculators, you might want to just pull them out really quick here at the end. This is not a 2-column proof, okay? Because of this word right here, find. All right, it doesn't, if it said prove, then yeah, I'd set up a 2-column proof, statements, reasons. But when it says find, let's find it, all right, algebraically. So here we go. Look at, I do provide you with some givens though. RST, everyone see that line, RST? Everyone see ray SQ, they're perpendicular, which means what should you be putting on your diagram right now? Right angle measures, yes. So angle RSQ is a right angle, and so is which other angle? TSQ or QST, yes. I'm only going to put one. If you want to put the other one, feel free. All right, here we go. Find the measure of RSQ. Well, I think we already talked about that, didn't we? What's the measure of RSQ? 8, what's the measure of RSQ? 90 degrees. Now here's the change up that you're probably not going to like, is the rest of the directions. Find all these angles and justify. How do we know it's 90? Why did you put a right angle symbol there? Why did we put a right angle symbol? What told us to put a right angle symbol other than me? Perpendicular lines form right angles. So now it's kind of like an algebra proof. What you write down, justify it with a theorem or postulate. Let's keep going. What's the measure of QST? That is also 90. How do we know? Because perpendicular lines form right angles. Let's keep it rolling. We got one more. What's the measure of angle TSU? Well, remember, we didn't fill in the other given yet, which was RSU is 89. So that's 89 degrees RSU. So what's TSU then? And I'm going to ask yourself to back it up. Will?
91.
Okay, you are correct in the 91. That's half the battle. How did you know it was 91?
Because RS, well, you have to
So you did 180 minus 89? Okay, that's fine. Algebra-wise, that's fine. But talk to me. How'd you know why it was 180 minus 89? A straight line equals what? 180. Okay. Also, another way we could tackle it is, and I'm going to force you to use this vocab. Tell me what type of angles those two are. Other than supplementary and adjacent, what's the key phrase we have for it? Linear pairs. And what do you know about linear pairs? They are supplementary. Yes. So you can say straight angles add to 180, like Will said, or you can say linear pairs are supplementary. All right. Either way. Be prepared to do that tonight on the homework when it says justify. Tell me why. Give me a theorem or a postulate that tells me how you got that number. Questions? Okay. By the way, do not give up on any of these proofs this weekend. Do not just write in the givens. Try to find something to write in. Look back at old proofs, please. Because those pink theorems are just going to get longer next week. All right, starting on Monday. And by longer, I mean there's going to be more of them up there.